Okay, so for this resource, what I'm doing is I'm using some the key principles in relation to constructing a parabola of a conic section. So in a school environment, what I would simply do is I would present this cone straight to students and go, the principles relating to a parabola would be that a plane would be cutting the conic section in a plane that's parallel to the edges of our cone. So I'd introduce this as our topic, and I would introduce then the idea of what a focal sphere is in order to construct our conic section. So what students might not understand would be the links between a focal sphere and, we'll say, the directrix or the focus or vertex of our conic section. So like these terms are very broad and might be difficult for students to understand. So I feel that this resource can clearly demonstrate how we get these points in relation to a parabola. So what I've done is I've made this dynamic resource then in relation to this this cone, sorry, in order to demonstrate how we find these terminology in relation to the topic. Pardon me. So what I've done is I've made this a dynamic resource that can be adjusted in accordance with whatever parabola is being created. So this plane is parallel to this edge of our cone. Always is, no matter what way I pull. That will not change, no matter what I move my focal sphere. So my focal sphere doesn't have to be a stationary thing. It can be moving along as long as the properties of the sphere stay the same. Now, the properties of that sphere mean that it has to be a tangent to our cutting plane, which is this one. It has to be tangential to the edges of our. It also has to be tangential to the edges of the cone, both edges of the cone. That means it's a sphere touching constantly within our object. So if you were to view that as a ball inside of the cone. Now, we're using this then to describe the principles in how the vertex, focus, and directrix of our focal sphere, of our parabola, sorry, are formed. So this way then we can show that there's three ways, the 3 points of contact that provide us with this information. So the first point of contact is where where we find our focus, sorry, is the first one. It's where the tangent is where the point of contact between our focal sphere and our cutting plane gives us the focus. And when we project that up perpendicular, we'll get the focus lying on the axis. The second point then is where our cutting plane intersects with the edge of our cone, gives us the vertex of our parabola. So imagine that would be, we're looking at it like that, the top of our vertex would be where that plane meets the very top last point in which our plane cuts our cone. And finally then, our directrix is where where the cutting plane meets the section where our focal sphere meets our tangents, or sorry, our edges of our cone. So when we project this line out from the points of contact between our focal sphere and our cone, we will get a point that meets the directrix, or meets the cutting plane, and we can project this point up. We get our directrix, our vertex, and our focus. And this dynamic model, which I created, should be able to help students better understand that you can constantly that this focal sphere, sorry, can constantly be adjusted, and we'll get different measurements as a result. Now, if another thing I would do then is I can show then that this is the plane we're being projecting, and the final thing I do then maybe is if I was in a lesson, I could just go extrude cut, and I would cut through our surface. We go through all, cut through our plane, and then by result then the shape we get here. This is the parabola. Sorry, is this what we should get, and should match the shape produced up in this view here.